You know that incredibly frustrating feeling when you're staring at a really dense, complex piece of text?
Oh, yeah. Where your eyes are tracking the lines, but your brain is just totally checked out.
Exactly. You realize you've just skimmed like 3 entire pages without comprehending a single word.
Right. You reach the bottom of the page and just think, wait, what on earth did I just read?
It's the
Wow.
worst.
Yeah.
And it happens to everyone.
It really is a universal cognitive experience because, I mean, you're decoding the shapes of the letters and you're converting them into sounds in your head, but you aren't actually metabolizing the meaning.
Yeah, it's like the working memory buffer in your brain just gets totally overwhelmed.
Exactly. The cognitive bridge basically just washes out completely.
The cognitive bridge is out. We've all been there. But, I mean, just imagine experiencing that exact cognitive disconnect when you're, say, a 12-year-old trying to read a 300-year-old primary source document.
Oh, man, that is a recipe for disaster.
Right? So today we are taking you on a deep dive into a really fascinating set of notes from 2 teachers. There's Sarah, who's a middle school English teacher, and Marcus, who teaches history and social studies.
And they are actively trying to solve this exact problem, right?
Yes, using this educational platform they're discussing, which is called the Interactive Reading Coach.
Which is super cool. But our mission for you today actually goes way beyond just looking at a new piece of classroom technology.
Yeah, definitely. We're going to really unpack the actual psychology of how human beings read.
Right. We want to look at the mechanics of how and why we fail to comprehend complex information.
And more importantly, how behavioral design can actually force our brains into deliberately processing text, rather than just blindly guessing our way through it.
Okay, let's unpack this. Because Marcus, the history teacher in our source material, he's facing a problem that adults deal with all the time, just in a slightly different context.
Yeah, his students are encountering these incredibly dense history texts, and they're essentially hitting a brick wall.
So they deploy a survival tactic, which makes total sense.
Right, they just skim the chapters, they look for keywords, and then they basically just guess blindly on the comprehension worksheets.
Which honestly is a completely logical defense mechanism against cognitive overload. I mean, the brain always wants to conserve energy.
Naturally, if reading a text requires just way too much friction, the brain looks for the path of least resistance.
Exactly, which is skimming and guessing. So the interactive reading coach addresses this by looking at how a reader approaches the starting line.
They realized they had to break that deeply ingrained skimming guess habit before the student even looks at the first paragraph, right?
Right. And that brings us to what the platform calls the pre-reading launchpad.
Yeah, according to Sarah's notes, this is a mandatory 3-step brain priming sequence, and you cannot bypass it to get to the reading.
I love that. It kind of reminds me of like stretching before a really heavy workout.
That's a perfect analogy. You can't just walk into a gym and try to lift a 300-pound historical text totally told.
No, your brain needs to warm up the specific neural pathways related to the topic.
So, step 1. The psychological term for that first step is schema activation.
Right, where the system asks personal connection questions to build up that background knowledge.
Because your brain desperately needs a mental framework, like a schema, to hang all this new information on.
Yeah, I mean, if I hand you a complex text about the American Revolution without any context whatsoever, those facts just have absolutely nowhere to anchor in your neural network.
Exactly. So the schema activation builds the anchor. And then the second step is this vocabulary matching game.
Which isolates the high-risk, really difficult words that are going to pop up in the text, and it forces you to interact with them before you even start reading.
And the final step is mission identification. It basically gives the reader a clear, explicit purpose.
Right, so you aren't just reading to survive until the final page, you know. You're reading to actually find something specific.
Wait, I have to channel my inner skeptical middle schooler here for a second.
Oh boy, go for it.
When I read about a mandatory vocabulary matching game, my immediate thought was, kids are just going to randomly click through the combinations as fast as humanly possible just to make the game end.
Oh, 100%. Adults do this all the time, too, like on those corporate compliance training videos.
Yes, you just click every single button until the screen finally lets you move on.
Well, the developers actually anticipated that exact behavioral loophole.
Really? How do they stop it?
They built in this thing called a pre-reading vocabulary cooldown mechanic.
Okay, a cooldown mechanic. How does that work?
Basically, if the system detects that a student is just rapid-fire clicking to beat the game without actually reading anything, the board temporarily locks down.
Oh, wow. It just freezes them out.
Yep. It freezes for like 3 to 5 seconds and flashes a warning that says, read carefully, locked for 3 seconds.
That is a really clever behavioral disruption. Like you try to take a shortcut, and it actively penalizes your time.
What's fascinating here is how this brilliantly disrupts what educators call the process of elimination strategy.
Right, because in a normal matching game, random clicking eventually gives you a dopamine hit when you just stumble onto the right answer.
Exactly. But the cooldown mechanic completely severs that dopamine loop.
By introducing that tiny 3-second point of friction.
Right, and it forces deliberate cognitive processing. The user quickly realizes that mathematically, actually reading the vocabulary words is the faster way to get through the exercise.
That is so smart. It literally trains the brain to slow down.
Yep. So the schema is primed, the vocabulary is mapped out, and the blind guessing loophole is closed.
But then, the student actually has to sit down and read the historical document.
Right, the actual hard part.
And Marcus points out a massive hurdle here, particularly for his ESL students, his English as a second language students.
Oh, sure. They hit this wall of archaic 18th century phrasing, and their working memory just completely overloads.
Because language evolves constantly. Asking a modern middle schooler to process a document from 200 years ago, it just introduces an immense amount of syntactic friction.
So to mitigate this, the platform uses what they call active in-context scaffolding.
Sarah describes this as the text basically refusing to be static. It's not just flat words on a screen anymore.
Right, so if a student encounters a really difficult word, they can just hover their cursor over it, and a pop-up synonym window provides a student-friendly alternative.
Which is great to keep their reading momentum alive. But the feature that really changes the game for historical texts is the pronoun trap anchor engine.
Oh, this is brilliant, because pronouns are notoriously devastating in history texts.
They really are. You might have a single paragraph describing an interaction between, say, George Washington, Thomas Jefferson, and Alexander Hamilton.
Right, and the text will just say, he argued, and he replied, and it was decided.
It's pronoun soup. The reader completely loses track of the subject. A sentence like, he told him that his plan was failing, well, that requires the brain to simultaneously hold 3 different identities in its working memory buffer.
Which is exhausting. The kids lose the thread, and the paragraph just turns into total nonsense.
But with this anchor engine, those ambiguous pronouns actually become interactive.
Right, so if you tap on the word him, the interface visually draws this soft digital string, pulling your eye directly back to the original noun subject.
It makes the invisible mechanics of syntax totally visible.
Exactly. When the working memory buffer overloads trying to remember who he is, the digital string basically offloads that cognitive burden right onto the screen.
Here's where it gets really interesting, though.
Okay, hit me.
As much as I appreciate the visual of that digital string connecting the thoughts, I have a pretty serious question about the long-term impact here.
Like a dependency issue.
Exactly. If the text is constantly holding the reader's hand, with pop-up synonyms and little grammar strings mapping out all the answers, aren't we just creating a massive cognitive crutch?
It's a very valid concern.
Like, how does a student ever learn to read independently if the app is constantly doing all the heavy lifting for them?
Well, you're right. Over-scaffolding absolutely creates dependency. If you leave those supports turned on indefinitely, the student just never develops their own internal reading strategies.
So how do they get around that?
The platform actually addresses this through a mechanism called adaptive scaffold fading.
Scaffold fading. That sounds like a workout for your brain.
It kind of is. It operates on a stepladder framework, meaning it dynamically adjusts the level of intervention based on the student's real-time progress.
Wait, so does it eventually take the training wheels off entirely, or is it just a gradual process?
It is a highly gradual process. When a student tackles their first passage, they start on level 1.
Okay, and level 1 is the full training wheels.
Exactly. That provides full accommodations, the pop-ups, the pronoun strings, all the direct assistance.
Got it.
But as they demonstrate comprehension over time, the system dials down the support and moves them up to level 2, which is known as the faded nudge.
The faded nudge. So instead of giving them the answer outright, it changes the type of interaction. What does a nudge actually look like in practice?
Good question. So instead of drawing the string directly to the exact noun, the system might drop a metacognitive prompt.
Like a pop-up question.
Yeah, a box might appear saying something like, look at the previous sentence. Who does she refer to?
Oh, wow. So it shifts the cognitive load right back onto the student.
Exactly. It's forcing them to do the diagnostic work themselves rather than just passively receiving the solution.
It prompts metacognition, which is Basically, the act of thinking about your own thinking.
Right. And once they master that self-monitoring, they finally transition to level 3, which is autonomy mode.
And I'm guessing autonomy mode is just reading normally.
Pretty much. All the visible hints disappear entirely, so to the student, it just looks like a standard, unassisted piece of text.
But the system is still tracking them in the background, right?
But
Like it doesn't just abandon them.
oh, continuously tracking. If the system detects that a student is pausing for an unusually long time on a known trapped sentence, a sentence flagged for difficult syntax or ambiguous pronouns, it knows the student is in a cognitive tailspin.
Even if the interface isn't actively intervening on the screen.
Right. It's pushing them toward independence, but it's constantly watching those behavioral metrics.
Okay, but that naturally brings up a major logistical problem for the teacher, though.
Oh, the grading problem.
Yes. If the system is dynamically adjusting the level of help for every single user, like if student A gets full pop-up hints and student B gets 0 hints, how do you grade that fairly?
It's a huge issue.
I mean, if a student scores 100% using hints on every single question, the teacher's gradebook is just totally compromised. It looks like the student achieved mastery, but they actually just leaned on the software the whole time.
Yeah, if the platform only relied on one basic metric, the data would be utterly useless to an educator.
Right.
So to solve that grading dilemma, the system utilizes what they call a decoupled scoring engine. It actually tracks 2 completely separate realities simultaneously.
So it basically separates the raw data from the gamified experience that the student sees.
Exactly. The first track is raw diagnostic accuracy.
And that's just for the teacher.
Right. This metric is kept pristine and clean on the back end, strictly for the teacher's dashboard. It measures whether the student fundamentally understands the cognitive domains being tested, and it completely factors out the accommodations.
Okay, that makes sense. And what's the second track?
The second track is the gamified earned points. This is the forward-facing score that the student actually sees and interacts with.
And this is where behavioral economics really comes into play, isn't it? Because if there's no penalty for using a hint, students are just going to spam that hint button on every single question just to secure a perfect gamified score.
Oh, without a doubt. They will optimize for the points, not for the learning.
So how do they fix that?
The platform penalizes the gamified earned points whenever a clue is used.
Hey, so there is a cost.
Yeah, if a student answers correctly but they relied on a scaffold, they receive, say, 0.5 points instead of a full 1.0 point.
That's brilliant. It satisfies that human desire for gamified progression, but it keeps their behavior totally honest.
Exactly. It ensures they only use the hints when they genuinely hit a wall and really need them.
So decoupling the scores protects the pedagogical integrity of the teacher's data.
Right.
And that data feeds into what Sarah and Marcus seem the most excited about in their notes.